v by, I don't remember exact, by di, and we just integrated it simply as minus v by r minus I. So I'm going to show you how we came to this conclusion, and I'm going to do two questions here, and we'll probably end it here, or maybe I will do one more topic. I will do one more topic and end it. It's already going for too long. I also need to study myself. I'm sorry. I'm trying my level best over here. Anyway, so let us assume a function f of x which on integration gives capital Fx. Okay. Now we have to find integration f of ax plus b dx is equals to what? Okay. So let us now, there is no way for me to prove this like how I did the previous example. I just use existing formulas and then I gave you the answer to give you a standard integration, which is like this, and this two standard integration values I reduced using previous knowledge and some clever trigonometry. But there is no way for me to do this using old formulas. I have to use substitution. In substitution, we usually assume something to be equal to something. Now, let us assume this function. Actually, we don't. We can assume not only t. You can assume z, alpha, beta, gamma, delta, zeta, theta, anything. I do not really care. Let us integrate this now. If we just simply put it, then we'll get something like this. And you cannot have a function of t and integrate it with respect to dx. You cannot do that. So what we are going to do, we will try to replace dx here. Now this is basic of substitution. Ax plus b is equals to t, I have assumed. So let's differentiate it with respect to x. So we get dt by dx here. And we what we get here? A dx, because differentiation of b is 0, x is 1. We get a dx here. Sorry, we do not get a dx, we get a here. So dt is equals to a dx. Okay. Now let us see our original function once again. We have dx here. We have f of ax plus t, which we can simply put t here, but we do not have an a here. I have found out a dx. So what can we do? We can write it as dt by a is equals to dx. Now let us replace everything so that we get a function of t and integrate it with respect to t. Okay, so what we get is f of t, and dx we have to replace by dt by a. dt by a. Now this is a constant, it will come out of the integration. So 1 by a integration f of t dt. So we get f of a, and I have assumed that integration of f of x dx is equals to f of t. Now changing the variable does not change a function. It will give me f of t. If you are confused about this, think of it as x square and t square. Do they, y is equals to x square, y is equals to t square, do they have any different meaning? They do not have any different meaning. Changing the variable does not change. Let's assume a function f of x is equals to x square and f of t is equals to t square. At t is equals to 1, at t is equals to, let's say, minus 5, you get 25 here. At x equals to minus 5, you get what? 25 here. Changing the variable does not change the function. So it will give me f of t only. Now what have I assumed t? I have assumed t as ax plus b. Obviously plus c will come, and that is how we have multiplied. You can see the very first example that I did. This is not actually example, I was just saying. This is b here, okay? This is the b here. This is b, and what is your a? A is -1, and you can see that that we have multiplied -1 here, and b ax plus b, where x is I here. So that is very cool. Now I will show you some questions here which are important to be discussed in this situation. The first question that I should discuss is integration of cos cube x dx. Now, people, we know that cos 2 theta is equals to 2 cos square theta minus 1. Now this is cos square and we have cos cube. Do we have any standard integration that involves cos cube? We don't. So we have to use basic trigonometric